Hello everyone, I want to take this opportunity to make a quick video to show you how you can go about drawing a Lewis dot structure of an ion. You can't do a Lewis dot structure for an isotope because it's just referencing neutrons, but with this, with electrons, we could actually draw a Lewis dot structure for an ion, either a cation or an anion. So let's do one for both. Let's start with an element scandium. Kind of a little weird out there, but scandium is located right here on the periodic table. It's actually in the third group and the fourth period. So if I was drawing an electron configuration for this, I would need to go up to 4 electron orbitals or electron levels. But I'm not doing that here. All I'm doing is trying to do the Lewis dot structure of this element, but it's become an ion. All right, scandium in this instance has become a +3 charge. That means it's lost 3 electrons. Now, why would it do that? All right, I'm just going to kind of do this the cheat way, but if scandium has 21 protons and 21 electrons, that means it would have 2 electrons in the first energy level, 8 in the second, 8 in the third, so that's what, 8 plus 8 is 16, plus 2 is 18. It has to put 3 electrons in its fourth energy level. It needs 5 more electrons. It's probably not going to be able to just to pick those up or bind to other elements and get them. So what it's going to choose to do is, like we saw in our last video, is become an ion. So it's going to throw away those 3 electrons. Just get rid of them. Now it drops down to the third energy level, which is filled. That becomes its valence shell, follows the octet rule. It's now happy. It's just gained a +3 charge, or a 3+. Either way is fine. +3 or 3+, same thing in my book. All right, for this. So if I were to ask you, give you an example like this, scandium +3, I could ask you, okay, how many protons does it have? Well, that's not going to change, right? It's still going to be 21, whatever the atomic number is. For an ion, it's the electrons that change. So it's a +3 charge. That means it's lost 3 electrons, so now its electron number is actually 18 in this form. And then for as far as the neutrons go, nothing changes. Let's take that mass number, let's round it up to 45, subtract the top number 21, and again I am getting 24 for my neutron number. But now I want to draw the Lewis dot structure for this ion of scandium. Now when you draw the Lewis dot structure for an ion, you have to first use these brackets that you can see in the images I've already provided. Because what you're going to do is, outside the brackets, it's going to be important that you also show me what the charge is. Alright, so the charge has to go outside of these brackets. Now, inside the brackets, what you're going to do is, you're going to write the symbol. And now you need to place for me the electrons, just like we did for standard Lewis dots, starting at the 3 o'clock hour. But what you're going to do now is, you're going to draw 8 electrons because now that outer valence shell is the one that's filled and the one that's being used. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8. So it's a +3 charge, but by doing that is drop down to its third energy level, where its octet is already filled. Now it's stable and it's happy in its present form. So that's how you would go about doing that. Now if you take the element sulfur, I have sulfur as a -2 charge. Now again, sulfur on the periodic table is over here. It is in the 16th group, so it's going to have 6 valence electrons normally. And it is in the third period, so it's normally using 3 energy levels. So if I come down to sulfur and cheat, that means if I were to draw the electron configuration normally, it would have 2 in the first, right? 8 in the second ring. That's for a total of 10. And I'm going to put 6 in the third energy level. Now, it's only 2 away from reaching 8, its octet. So again, what I said in the last video is most of the elements over on the right-hand side of the periodic table are the ones that would become anions. Up top, we just talked about a cation. Now we're going to deal with an anion, since sulfur is going to gain a negative charge that you can see. It's going to gain a -2. It only needs 2 more electrons, so the odds of it just finding and picking up 2 more electrons from some other element like scandium that threw away electrons are pretty high. So once it gains those 2 electrons, it's going to fill its outer energy level and become stable. So before I draw the Lewis dot for this, let's just go through our regular routine here. Proton number will not change. It's going to be 16. But now for electrons, you have a -2 charge. You've picked up 2 electrons. So now your electron number is actually 18, just like it was up top, coincidentally. For neutrons, I'm going to take the atomic mass over here, round it down to 32. Subtract the top number, which is the atomic number. And again, I'm going to get, in this instance, 16 as my number of neutrons. Now, if I want to draw the Lewis dot structure for this, I would do my brackets first, like you see, but I already have. I would draw those. I would put what the charge is outside, either 2 negative or -2. Either one is sufficient for me. I'm going to put the elemental symbol as sulfur. Realize what energy level I'm using, which is the 3rd. How many electrons are there total? Well, it's not just 6. I picked up 2, so it's really going to be 8. So now I'm going to draw 8, starting at 3 o'clock. 1, 2, 3, 4, 5, 6, 7, and 8. So I'm done. Excuse me. If you haven't noticed, pretty much anytime you have a positive or negative anion, if you draw the Lewis dot, they're still going to have 8 electrons now in that energy level that you're drawing, either because they drop down to it, like you did for scandium, or you've added electrons to fill the outer energy level for sulfur, like we did there in that example. So once again, most of the elements that are going to become a cation and lose electrons, like we did up here, are going to be in either group 1, 2, 3, or 4. While the majority that we're going to focus on that are going to become anions will be in groups 15, 16, or 17. Not group 18, because those are the noble gases and they're already filled. Alright, so you're going to have a homework assignment on how to draw Lewis dot structures for ions. You want to take this information and do it exactly the same way on your homework.